Good morning, sir. I'm Princeton Ruth, and I'm showing my first data mining lab exercise. Here I have used car automobile data as my input data. I have changed it to attribute values if the attribute is actually int and it is showing as polynomial. I have changed it to int and such that for all the attributes. And for handling missing values, I have used this replace missing value algorithm. And the filter type, I have used all. And I have used average as default for all the attributes. And if I run this, the attributes which initially had missing values will be replaced with its own average values. And here are the attribute to first three columns had missing values initially. Now it has changed to 122, which is its average value. And if I give 0 and run, the attributes which initially had missing values will be replaced with the zeros. And also, if I give value and I give mm, some integer value, the attribute which had missing value will be replaced with 50. Like as I shown, attribute to initially had missing value. Now the missing value is now replaced with the 50, which the data I have inputted. And now the next is moving to discretization. Discretization, I have used this discretize algorithm here, which is here. And number of bits I have used 2. And okay, I'm giving short. If I run this, it shows the range from 0 to 2. That is only maximum number of bins it can hold is 2. And within that range, the attribute value will be distributed. See, least is range 1 and most is range 2. Here it shows what are the ranges it has used. And then if I give interval here for the same number of bins, between it includes the interval, that is some values it include within, that is infinity to 0.5 and up to 113, like that. It split up the data into intervals, and if I increase the number of bins as some more values, the short, you could see a difference in this one. Up to 5 ranges, the data can be put into 5 different bins. And you can see the least is range 1 and the most is range 2. And you can see what are the bins it has used. All the bins it has used in attribute 1. See range 2, 1, 4, 5, and such that. And for sampling yes, sampling I have used a sampling algorithm and I gave sample space as 100. Now what it does it splits up the data into 100 sample spaces. Okay. And if I give increase the sample size with some more value, like 500, it results in an error because the sample size, I mean the input data does not have that much sample space, and thus it results in an error. And the next is normalization. In normalization, I have used this normalize algorithm. I have used range transform here. Now let me use Z transform first and I run it. Z transform, it uses the Z transform algorithm and shows the result. Now you can see. And the range transform, my minimum is 0 and maximum is 10. So the result will be as such the starting value, that is the minimum value will be 0, and the maximum value it can extend will be 10. More than 10 it will not go, and if I need that, I can increase my range always. Here I made it as 20 and I run it. You can see attribute 20, attribute 1. First two rows, the maximum value, it increased to 20, which is the highest maximum value. And if I give interquartile range, you can see the result. It splits up the result in quartile range. And same as proportion transformation, in which it uses the algorithm to show the result in the proportion transformation. Now the last is correlation. The last is correlation determination. I used this correlation matrix as my algorithm. It gets the input from my input data, and it makes the output result in a matrix format, which is this. And if instead of normalized waves, if I clicked squared correlation, the result will be as such. Yeah, you could see the difference in that. Now that's all for the exercise one in data mining. Thank you.